So now that we have this concept of future value, it can be useful to think about it in reverse, present value, which is, suppose we want to know how much to save to get to some future amount. In your budget rough drafts, a lot of you had mentioned that you're saving up for families. If you want to send your future children to college, for instance, and you know that in the year 2050, college is going to cost $1 million, how much do you need to start saving right now to be able to afford $1 million worth of college in 30 years? Well, to answer that question, we use the present value formula. Present value is the value today, in the current time, in the present, of a payment that is promised to be made in the future. Alternatively, present value is the amount that must be invested today in order to realize that specific amount on a given future date. So let's talk about discounting to the present value. And when I use this phrase discounting, it means that we're talking about present value. To discount to the present value, we need 3 pieces of information. And remember, this is just future value in reverse. So what information do we need? Well, we need that future amount, the fact that in the year 2050, college is going to cost $1 million. We need to know the prevailing interest rate, how is money growing over time, and we need to know the period of time. So from today to the year 2050 is 30 years. In other words, we're just thinking backwards. This is the opposite of compounding. Discounting is the opposite of compounding. So how do we discount to the present value? Well, we can derive the equation just from our future value equation. Remember, future value is this concept, present value, the amount we have now, multiplied by 1 plus the interest rate raised to the time horizon. The derivation is really simple. We just divide both sides by this quantity, 1 plus r over n. And that gives us our present value formula. Present value equals future value over this quantity 1 plus r raised to the n. So let's do some practice. What we want to know is if we're going to get $100 a year from now, if we're going to get a check in 1 year worth $100 and the prevailing interest rate is 5%, how much is that future check worth today? So press pause on your keyboards, stop the video, and take a second to try and figure it out on your own. So to get that answer, we just go right to the formula. 1 plus the interest rate is 1.05. It's only 1 year, so we're only raising it to the first power. 1.05 is just itself. And then we go ahead and divide. So the present value, 100 over that amount, is $95.24. And the cool thing is we have an easy way of checking our answers, which is we can take that amount, $95.24, and plug it into the future value formula. And from plugging it into the future value formula with a time horizon of 1 year, we get our original $100. So we know we did it correctly. Let's try another example. This time, we're receiving a check in 2.5 years. So we're receiving a check in September of 2022. And we want to know how much it's worth if we have an 8% interest rate. So go ahead and press pause on this video, take a minute to try and figure it out on your own. And again, to get that answer, we just plug it into the formula. We have 1 plus our interest rate, that's 1.08. We have our time horizon. We take this amount and we divide $100 by this amount, and we get $82.50 as that discounted amount. So $82.50 is going to be worth $100 in 2.5 years if the interest rate is 8%. And again, we can check our answer by plugging it back into the future value formula, and we get $100. So we know we did it correctly. So, between our discussion of present value and future value, we should have noticed a couple important properties of present value, a couple key relations between this concept and the information contained within. So what creates a higher present value? Well, present value is higher when future value is higher. These two are directly related to one another. And present value is higher when time horizon and interest rate are lower. These two are inversely related to one another. And take a minute to think about why this might be the case. So, if we have a low interest rate, our money is not going to grow very quickly. So if we have a relatively low interest rate, future value and present value need to be closer to one another. Similarly, if we have a short time horizon, there's not a lot of room for our money to grow. So present value and future value need to be very close to one another. But for a very high future value, we need more money. And so present value needs to be higher for that amount. We can explore this relationship graphically. Here we have $100 discounted at 5% interest rate. So note that at time equals 0, future value and present value are the same thing, $100. And we can explore this relationship where at $50 present value, or at 14.4 years, present value is $50, and at 28.8 years, present value is 25 years. Keeping in mind, the longer the time horizon, the lower the present value. So let's close this little lecture nugget with two examples for you to try on your own. These examples should look reasonably similar to the ones we did with future value. The key difference here is that with the second example, we're only discounting for 1 year. To that end, note that when we say discount, it should imply present value. And keep in mind, this one is only 1 year. So try it arithmetically, try it with the formula, and we'll come back with the next little lecture nugget and explore it as a class.